Okay, when a boy pushes a toy cart along a level road and let it go, the toy cart will have kinetic energy, and when it slows down, it's most probably due to friction, and friction produces heat, so the kinetic energy is being converted to heat energy, and the answer will be okay. Let's try to visualize this question. We have an object that is placed 20 meters above the ground, and when it's almost touching the ground, right, it has a speed of 20 meters per second. So when it's at the top, this object will have gravitational potential energy. It can be calculated by the formula mgh. So it will be 4 times 10 times 20. This will give us 800 joules of energy. And when it's almost striking the ground, it will have kinetic energy. So kinetic energy is equal to half mv square. This will be half times 4 times 20 square. Down here we will have 800 joules of energy. So we can see that all the gravitational potential energy has been converted to kinetic energy when it falls down. And we are given the information that the object does not rebound. So if the object does not rebound, that means all the energy must have been converted to heat and sound energy. So the total amount of energy that is converted to heat and sound, it will be the full amount of this 800 joules. Answer C. Okay, in this question we are asked how is the heat being transferred through the base of a metal saucepan. So we have to understand that the metal is a good conductor of heat. So the process by which heat is transferred through the metal saucepan, right, it will be by conduction only. A. Okay, in this question we have a piece of wire having a resistance of 2 ohm in melting ice, which is 0 degrees Celsius, and a resistance of 2.5 ohm in boiling water of 100 degrees Celsius. So we can say that when the temperature changes from 0 degrees Celsius to 100 degrees Celsius, the resistance changes from 2 ohm to 2.5 ohm. That means a change of 100 degrees Celsius of temperature, it will bring about an increase of 0.5 ohm of resistance. Okay, so now what is the resistance at 20 degrees Celsius? So from 0 degrees Celsius to 20 degrees Celsius is a temperature change of 20 degrees Celsius. So if let's say 100 degrees Celsius change in temperature will bring about 0.5 ohm change in resistance, 20 degrees Celsius it will bring about 20 over 100 multiplied by 0.5. It's going to cause an increase in resistance of 0.1 ohm. And the initial resistance is 2 ohm, so the final resistance, we have to take the initial, which is 2 ohm plus the increase of 0.1 ohm. This will give us 2.1 ohm as the final resistance. Answer should be A. Okay, in this experiment, 1700 joules of thermal energy is used to heat up some ice. So using the formula, Q is equal to mass times the specific latent heat of fusion, we can find out what is the mass of ice that will melt given this amount of thermal energy supply. So mass is equal to the thermal energy divided by specific latent heat of fusion. Okay, that will give us 1 0.700 divided by 340. So this will give us 5 gram. So 5 gram would have melted, and that leaves us with 8 minus 5, which is 3 grams of ice left. So the answer is B.